Hi everyone, I chose Olympic National Park as my capstone project and their struggle of the invasive species in the park. Invasive species in Olympic National Park. The issue here is that people are introducing invasive exotic species into the park. These invasive plants cause major ecological damage to the park. Ecological changes to the park cause damage to all the wildlife and potentially the guests. Removing these species from the park is a tough job. They say there are two sides to every story, but in this case, there are far more negatives than there are positives to the park. These invasive species drive out native plants, they can sometimes carry disease to plants and wildlife, and they contribute to habitat degradation in several ways, which we'll talk a little bit more about in a second here. Some examples of invasive species and their impacts in the park. One of them are the wood-boring beetles. They carry disease and they kill the trees in the area when they spread around to them. There are quagga and zebra mussels, which I'm sure many of you have heard of. They drive out other native species and their larvae actually clogs water drains, which can cause a huge problem. There are over 200 species of non-native plants in the park. Some cause fierce competition for nutrients, light, space, and carry disease to other plants and possibly wildlife. So as you can see, they're a really huge problem here. These are pictures of Olympic National Park's worst invasive species. As you can see, we have Scots broom, Canada thistle, English ivy, English holly, Japanese knotwood, Himalayan blackberry, and herb Robert. The park says that before entering, one of the best ways to prevent this sort of thing is to actually know what you're looking for and know what to avoid and what not to spread around. So by taking a look at these pictures before entering the park, that can kind of help you to prevent the spread of these. One example of this degradation to habitat, like I talked about, is with Scott's broom. It's actually damaging the salmon population and the salmon habitat of the Hoh River within the park. One monoculture of the plant can produce up to 12,000 seeds in a year. These seeds can infiltrate the river and outcompete other species along the river. And because there are so many seeds, they pollute the clean water of the river. The plants change the chemistry of the soil and make other such changes to the salmon's habitat. So, above all, they're really changing the salmon's habitat, and it's becoming hard for them, especially with all of these seeds polluting the water and with the change of the chemistry in the soil. In a direct quote from a National Park Service's webpage on Olympic National Park, they say, they can affect fire ecology, water movement, soil erosion, native plants, and wildlife. The weeds do this by drying out wetlands, smothering native trees, poisoning animals, or causing other impacts. So as you can see, it's a huge deal. They're making a whole bunch of other changes to the ecosystem. They're driving out species, and over time, they just completely deplete nutrients of the soil. Some animals come around and they eat them, not knowing what they are, or having them be the only food source left, and they're getting poisoned from it. So not only is it harming the plants and that sort of thing, but it's harming the habitat and the food source for these animals as well. What is the park doing to combat this issue? Visitors are the main issue to this problem. The Park Services say that prevention is the best method. Park is urging people not to bring in foreign firewood, to clean their boats before entering the park, and to never bring any unnatural species into the park. The park uses herbicides, weed pulling, and other such methods to remove already established invasive species. But once a species has been established into the park, it is very, very hard to remove it because by then, usually it's already spread over miles and miles of land. Specific tips from Olympic National Park. Before entering the park, you're suggested to brush off your shoes, clothes, pets, stock, vehicles, tires, and any species that can carry seeds or plants. Do not throw fruit seeds or other trash in the woods. Learn to point out the invasive species in the park and try to leave as little trace as possible. This is a graph of the total recreational visitors in Olympic National Park from 1934 to 2017. As you can see over the years, a number of visitors is getting into the several millions, almost 4 million, and with that much traffic going through the park, we need to make sure that we're not bringing in these species and causing damage. What will happen if the issue goes unsolved? It may be more serious than you think. More native species will continue to die out, the invasive species will deplete the area of its nutrients, wildlife species will become unbalanced and die out due to poisoning and food change by these plants, and the guests may become harmed by the species and thus will stop coming to the park. If guests stop coming, funding will dwindle and the park will not be maintained. As little as a problem as it seems, it actually has a huge impact in the end and could actually be the end of the park and the natural beauty and wildlife and ecosystem that it has there. If you're interested, I sent a little link down below on a TED Ed video if you want to know more about the threat of invasive species. Alright, now we're going to shift gears a little bit and talk about the geology of Olympic National Park itself. Subduction zones and accretionary wedges. What is subduction? Well, dictionary.com says that subduction is the descent of one plate beneath another, or the sideways and downward movement of the edge of a plate of the Earth's crust into the mantle beneath another plate. Let's take a look at what this actually means. Here is a picture of a subduction zone. As you can see at the bottom, the red area, one of the plates is sliding beneath another. That dark red area you can see is the plate sliding beneath another plate, and that is subduction. This is just a bird's eye view of the picture that we just saw. On the very left, we had the Pacific Ocean, and then the Olympic Mountains, then Puget Sound, and the Cascade Mountains. So that's just kind of a bird's eye view of what we looked at, and we'll look at that a little bit closer in a second here. Now you might be asking what an accretionary wedge is. Again, according to dictionary.com, it is a mass of sedimentary material scraped off a region of oceanic crust during subduction and piled up at the edge of an overriding plate. Let's take a look back at our picture again and see what that looks like. So here is that picture again. You can see the plate sliding beneath the other plate. If you take a look at that little yellow triangle in between those, that is what the accretionary wedge is. It's that sedimentary that is scraped off and creates kind of a little. Alright, so in the case of Olympic National Park, we can see again that top eye view. Number 1 is the Pacific Ocean, number 2 is the Olympic Mountains, number 3 is the Puget Sound, and number 4 is the Cascade Mountains. And again 5, that little triangle there is on the accretionary edge, on the edge of the Olympic Mountains. So that is kind of the bigger picture of how that got to be there and what it means for the mountains. Looking at some bigger picture stuff here, we're going to talk about plate tectonics. Plate tectonics are the basis of all geological features. Dictionary.com describes it as a theory explaining the structure of the Earth's crust and many associated phenomena as resulting from the interaction of the rigid lithosphere plates that move slowly over the underlying mantle. This is an example of some plate tectonics around North America, where we live right now. In the case of Olympic National Park, you can see the Juan de Fuca plate right up against the North American plate. The Juan de Fuca plate subducts under the North American plate, creating the Olympic and Cascade Mountains we know today. So the plates that we saw subducting underneath each other were the Juan de Fuca plate going underneath the North American plate, and that created the mountains we know as the Olympic and Cascade Mountains today, which we looked at just a bit earlier. Rock types of Olympic National Park. How rock types are made. Olympic National Park has all 3 of the basic rock types. This is just a little bit of information on how each is made and each of their roles in the park. Igneous, as you can see this little black one down here, is the cooling of liquid hot magma resulting in solidification. It's composed of usually hot magma. Sedimentary is the cementation and compaction of sediments. So they're identified by their grain size, classifications of clastic, chemical, and organic. And lastly, we have metamorphic rocks that are formed from extreme heat and pressure of previously occurring rock formations. They are identified by the intensity of foliation or by the banding and folding of their materials. This last slide is a list of my references, and that's about it. Thank you guys for tuning in, and I can't wait to see yours.